Hi, welcome back. So in this video, we're going to start talking about how we do transformations with the sine and cosine graphs. So we're going to build this up one transformation at a time, and I'm going to be showing some sliders using Desmos so you can kind of see how these transformations take place. And if you want to follow along, you can open up the Desmos link yourself and try these on your own. So we're going to do one transformation at a time. So let's start with A on the outside. So we're going to do A times sine or A times cosine. And let's talk about what this does. So when we have a value A and we multiply it by the function, this is a vertical scaling by a factor of A. And what this will do is it's going to change the current amplitude from 1 to A. So the normal amplitude of sine or cosine is 1, but this transformation is going to scale the amplitude to be A. So let's see what this looks like. So I have here sine and cosine graphed, and we have A as our slider that's being multiplied by the function. So we can see as A gets larger, the function is stretching vertically, and so we have an amplitude that's growing. You can see with A, we can also have negative values, and this is going to do a vertical reflection. It's going to reflect it across that horizontal axis. And so that is what the negative does if it's just a negative value. And then if we have a value between 0 and 1, the function is shrinking vertically, so the amplitude is shrinking. So basically it just scales to whatever that A value is, that becomes the new amplitude. Okay, for our second transformation, we're going to put a B being multiplied by the input of theta. So I see the A is happening to the output of the function since it's A times the sine or cosine value, but now we're going to transform the input. We're going to transform theta by multiplying it by B. So in doing so, this causes a horizontal scaling by a factor of B. So we're taking the input and scaling it. So that's why it's happening horizontally versus applying it to the output would be vertical, like an A. And what this does is it's going to change the period to 2 pi over B. So the reason why this happens is maybe not super intuitive. I like to think that it's taking the normal period, which is 2 pi, and it's just dividing it up into something smaller. So we're dividing it by B. Let's see what this looks like on the graph. So when we have B here, as B increases, so as the B value gets larger, our period is shrinking. So it's getting smaller and smaller, and so you can think of the function kind of compressing horizontally. Here, a negative B value is going to do a reflection across the vertical axis. So it's not going to look too much different because these functions have some symmetry to them, but that's what happens when it's negative. And if we're between 0 and 1, we're going to be stretching the period. So anytime you have a B value between 0 and 1, that period is getting bigger. We'll talk a lot more about the nuances of this when we start to do some examples. We're just getting the overview of what the transformations look like for right now. All right, our next transformation is also going to be applied to the input. We're going to take the theta value and do plus or minus c. So you'll notice here that I'm being really careful with the parentheses. The idea is that we do the plus or minus c first inside those parentheses, and then we take whatever that value is and multiply it by b. This is just so we really keep the transformation straight and we have the b and the c separate. So the plus or minus c is going to be a horizontal shift left or right. The plus c is a left shift, and the minus c is a right shift. If you've learned about transformations recently, this probably looks familiar. All these transformations are like any transformations on functions. We're just applying them specifically to sine and cosine. So this one's a little odd that the left is the plus and the right is the minus. That's just because we're applying the transformations to the input, so it happens a little differently. This type of transformation has a special name. It's called a phase shift. So we would say there's a phase shift by c. Let's look at what it looks like on the graph. So you can see that as c is a positive value, we'd be adding c to the input, and so we're moving to the left. Then when we have a negative c, we'd be subtracting that c, and we're moving to the right. All right, then our last transformation is on the outside. It was applied to the output, so we have plus or minus d. So because it's applied to the output, this is going to be a vertical shift, either up or down. Up would be the plus d, and down would be the minus d. And what this is going to do is it's going to change the midline to y equals either positive d or negative d. So normally the midline is y equals 0, and because we're shifting the graph up or down, that's going to also shift the midline. Let's look at what it looks like. So you can see here, as d is more and more positive, the graph is shifting up, and then as it becomes negative, the graph is shifting down, and you can see that midline shifting with it. All right, there you go. So those are our 4 transformations. I call them A, B, C, and D. This is just a personal choice to help me keep track of them, and it gives me some language to talk to students about. But we have 2 vertical transformations, A and D, and 2 horizontal transformations, B and C. In practice, the order doesn't really matter all that much because of the symmetry and the periodic nature of these functions, so I'm not going to worry too much about that. We will start working with some examples using both the formulas and the graphs in the next video, but that's it for this one. Thanks so much for watching, and I will talk to you in the next one.